Hey, what's going on, guys? Let's do this problem right here. The question is asking a particle with mass of 1.5 times 10 to the power minus 3 kilogram and a charge of 0.2 microcoulomb moves at velocity of 5 times 10 to the power 3 meter per second in the positive y direction, where a magnetic field exists of B is equal to 2.0 Ti and minus 1.0 Tj. What will be the direction of the acceleration? Let's see how we can find it. So first, let's draw the diagram for direction of this magnetic field. So this is given by 2 in the I, so it means x direction. So 2t in the I direction, and then minus 1t in the j direction, right? So the direction is going to be always like almost like this. If we draw, maybe it's like this, right? So it's going to go like this. Okay, this way. So let's see how we can. Now we have the direction of this one, and we know this is x component of this one. This is going to be y component, right? And let's look at the direction of this charge. They're saying 0.2 charge moves at velocity of 5 times 10 to the power 3 in the positive y direction. So here we are going to have the charge. Is the charge positive? Yeah, the sign in front of the charge is positive, right? So the charge is positive and it's going toward y direction. So this is going toward this, and here if you see by and charge I in the y direction, so there's no force going to be in the y direction, so force is only going to be in the x direction, right? So all you have to do is calculate the force in the x direction, and so that's it. And to find the direction of the force, what we do, if we set our right hand, so since this is positive charge, we have to use the right hand, and if you set your hand and bend according to this magnetic field direction, your thumb will be go inside, right? So the direction of this force is going to be inside, so we put x. This is going to be the direction, so f is going to be the so this is going to be the direction of the force that's going inside, right? Let's see what the question is asking. What will be the direction of the acceleration? So since this is the force direction of the acceleration is also going to be the same. And let's see, so to find the acceleration we have to first calculate the mass. So to find the mass we are going to use the force equation. Force is equal to q v bx. Since we only have this magnetic field in the x direction, we are going to use only bx. So bx sine theta. So what's going to be the sine theta here? If you notice that angle between this x and this charge is 90 degree. So that's going to be the sine theta. So we know that sine 90 is 1. We can just plug 1 right here. And Q is the charge that is provided, 0.2 microcoulomb. So that's going to be 0.2 times 10 to the power minus 6 coulomb. Right? V is velocity that's provided, 5 times 10 to the power of 3 meter per second. 10 to the power of 3 meter per second, and bx. So that's what bx is provided like this. So x in the x direction we have 2 Tesla. So that's what we are going to use. Y direction we don't have any force, so we don't have to be worried about that, right? We want to use this one, x direction one. So here we are going to use 2 Tesla. And if you calculate this one, that's going to give you 2 times 10 to the power minus 3 Newton. Since we have the force, now we can go ahead and use the Newton's second law to calculate the acceleration. So Newton's second law is F is equal to ma. So here A is going to be F over m, right? So F over m, we know the force already, that is 2 times 10 to the power minus 3 Newton, and mass is provided in the question, and we have to divide by that mass. So this is going to be 1.5 times 10 to the power minus 3 kilogram, and if you divide, you're going to get 1.33 meter per second square. Now we have to decide the direction, and we know that since force is going inside, this acceleration also going to go inside. So this is x direction, this direction is x, this is y, and inside is going to be z direction. And if we set z direction outside, this is going to be minus z, right? Inside is going to be minus z. So this is going to be minus z. So the value of this one is going to be minus 1.33 meter per second square. And since it is in the z direction, we put k, right? So that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.